The electronic circuit on the screen is an analog to digital converter and a digital to analog converter. The first circuit is the ADC, which take some voltage of reference that are made by resistors in series, and this voltage are compared with the voltage in the input of the IC. When the voltage in the input is higher than some reference voltage, this OP will generate a high or low signal, and this by a configuration by logic gate will create a digital value. And the second part is the DAC, in which are usually used also the OP. In this case, each interruption of the digital input switch this part are connected to a resistance. Each resistance has is connected to a reference voltage, and the sum of all the resistance that obviously are activated is amplified by this operance amplifier and generate an output voltage that must be equal to the input voltage. The ADC IC, the voltage, the negative voltage is connected to ground, and the positive voltage is varied by this potentiometer. In the pin of voltage reference, the voltage reference must be the half of the real voltage. Misery, because for the reason here I use it to resistance in series that with the same value. This IC is the ADC0802, and this IC needs a clock signal to generate each conversion. It doesn't convert in real time, you need a clock to do it. And these are the output. This IC works just with 5 volts, so we can apply any more voltage. And this show the binary or the bit that are activated when is some voltage here in the input. Right now, all the outputs are low because here must be 0 volts. This is a very low voltage. But when I increase the voltage here, the output voltage, the input voltage, sorry, generate a binary signal or value and disactivate the LED. Okay, this is a AB converter, and this is the half. You can see I activate the first 7 LED that correspond to the first 7 bit. When I apply the full voltage that is white, the 8 bits are activated. Now this DAC is the DAC 0800. This DAC works with less and plus 18 volts. This resistance in the reference, I use it with just 5 volts and a negative voltage of 0. The two resistance are of 10 kilo ohms. And in the IO and IO negative, I'm not using this part because, like I said, it's a IC with plus and less voltage, but I'm using just the positive voltage. I'm not working with negative, but the reason I disconnect this part, and these two resistance are connected to the reference voltage, that's 5 volts, and here you can see the voltage in the output. The negative part of the voltmeter is connected directly with the ground, and the positive is connected directly with this ion negative, but this is not used because if I connect this input I will obtain a negative voltage, but I don't need that. And like can be seen here, for the combination of the bit generate the maximum voltage that is 5, and here you can see the input voltage in the input are 5, and the output is a very close voltage to the 5, but here is not exactly because maybe for the source that is exactly 5 voltage and there is a loss, and almost when they are using some converter the voltage is not exactly the same. There is a difference, a very low, but there is a difference. I reduce the input voltage to half. Okay, this is the combination for just the first 7 bits, that is 128, and to represent a voltage approximately to 2.5 volts. This is just the approximately, not exactly. Well, thank you for watching this video.